Today we are going to look at formulas used in projectile. The first set of formulas I'm going to bring out that are the fundamental formulas used in projectile will be first, formulas for the condition when the projectile is projected at an angle to the horizontal from the ground, following what? A parabolic shape, having the shape as this. H being taken as the maximum height, theta, this point here C, or let me say B, C, from A, here is our arrow, let me call here capital H. So when the projectile is projected at an angle to the horizontal from the ground, the formulas we use in solving problems on projectiles are given as follows. A. Time to reach the maximum height. The time to reach the maximum height is given as small t equal to what? U sine theta all over g. This is time to reach the maximum height. Then we have the second, time of flight. Time of flight, capital T. The time of flight here is the total time it travels from the point of projection to the maximum height and back to the projection plane. So the time of flight is given as 2 small t, which is equal to 2 u sine theta all over g. We'll look at the maximum height, capital H. The maximum height, H, is given as u square sine square theta all over 2g. U square sine square theta all over 2g. Then we are going to look at the range. The range R is given as what? U square sine 2 theta all over g. These are the basic formulas for calculating problems on a projectile that is projected from the ground, inclined at an angle of theta to the horizontal. Now the various letters and symbols, they stand for 1. T, small t, time to reach maximum height. Our theta is called the projection angle. Projection angle, or is referred to as what? Angle of what? Projection. Our U is given as what? The initial velocity Our G is given as what? Gravitational acceleration. And the value we normally use for simplification is 10 meters per second squared. Then we also have capital T, time of flight. And our arrow is range. While our H is the maximum height. So we are going to look at formulas when a projectile is projected vertically upwards. Now, there's going to be a little modification for some of these formulas. When the projectile is projected vertically upwards, the formula for the maximum height is now reduced to this. H. Maximum height now becomes what? U squared all over 2G. As we can see here, that this formula basically, when the body is projected vertically upwards, what do we have? Our theta then is taken as what? 90 degrees at angle 90 degrees. So angle 90 degrees is actually what? 1. So simplify the formula into this. So U squared all over 2G. Then also when the body is projected vertically upwards, or the body is released from an height, drop from a given height, the time of flight or the time to reach the maximum height, if the body is thrown vertically upwards, is given as what? T, which can also stand for time of flight if the body is dropped from a height. T is given as what? The square root of 2h all over g. So this modifies the value when the body is vertically thrown. What do we have? The time to reach the maximum height and the time to drop back to the ground, they are normally what? The same time. So if we are talking about the time of flight, if the body is thrown vertically upwards and falls back again, it becomes 2 of this value. But when we are considering a value dropping from a given height, this time can be used to determine the time to drop from the maximum height to the ground, which also stands as our time of flight. We are going to look at another situation when the projectile is projected from a given height and is projected horizontally. A situation when a projectile projected horizontally from a given height with an initial horizontal velocity. Now let's say we have a height like this. This is the ground level and this is the height. And the projectile is projected with an initial horizontal velocity from this height. Now what happened? Let's take this to be our initial horizontal velocity and it's going down. So this is our A, and let me take here to be B. Here automatically becomes the range. So here the projectile is projected horizontally from a particular height. Let's take this height now to be H. That is the maximum height we have from the top of a building, H, and is projected horizontally. So we have a situation like this. Now, what is the time of flight in this situation? The time of flight in this situation is the same as the time of flight if the projectile is dropped from this same height. So time of flight under this situation is given as t is equal to what? The square root of 2h all over what? G. Where our h here stands for the height from which the projectile is projected horizontally. Then we also have what? Our range. What becomes the formula for the range here? The formula for the range, R is given as what? Ux what? T. Where our Ux here stands for what? The initial horizontal velocity. The initial horizontal velocity which the projectile is used to project from that particular height times the time of flight will give us what? The range. So the formula for range has been simplified to this form. If the projectile is projected from a given height at an horizontal what? Velocity,